Hello and welcome to Section 4 of 6 of Riverbed's RCSA exam preparation. I'm Bob Ashmore. I'm a Channel SE with Riverbed. Let's get right to it. Verifying the installation. When we install steelhead appliances, we should verify that they are working correctly. Here's how we do that. First thing we want to do is look at the interface statistics. So we go into Reports, Networking, Interface Counters. What we're looking for here is we don't want to see errors on the LAN or the WAN interface, which could indicate duplex or speed issues. Next, we want to determine which other devices the steelhead appliance is pairing with. We can do that by going into the Management Console, Reports, Optimization, Connected Appliances. The same information is available in the CLI using the command show peers. The GUI looks like thus. When you go into Connected Appliances, you can see the other devices that the steelhead has connected to through the auto discovery process. And you'll see the version of code and the hardware model that is being utilized by the device on the other side. Under current connections, we can see all of the connections that have been established and are being optimized by or unoptimized by the steelhead appliance. And if we click on the magnifying glass, we can drill into the details of a particular connection and verify that we are getting the type of optimization that we thought we were. Also, if we want to reset a connection to force that connection to begin optimization, resetting a connection, of course, causes a reinitiation using the three-way handshake, which allows Riverbed's auto discovery protocol to work. Also, we can check for asymmetric routes. We want to make sure that the asymmetric route detection that is automatically configured on the steelhead appliance has not picked up a route that it should not. In that case, we may want to clear that asymmetric route. Sometimes asymmetric route detection can incorrectly identify an asymmetric route if one of the steelhead appliances is being rebooted at the same time as the other steelhead appliance. In that situation, we'll need to go into the asymmetric route table, select the route that we don't want in the table, and click Remove Selected. Routes are placed in the asymmetric routing table for 24 hours. After that, they will automatically expire out of the table. So if some type of event occurs over the weekend, it will probably resolve itself by the time users come back into the office. Now we're going to go through a list of a bunch of different features and focus on the portions of those features that are covered in the exam. Authentication and authorization. Keep in mind that a steelhead appliance can use either radius, TACACS, or local authentication to allow an administrator to log into the device. Remember that TACACS goes over port 49, and the order in which authentication is attempted is based on the order specified in the AAA method list. Always make sure that the local value is specified so that if access to the radius or TACACS server is lost, we still have access to the steelhead appliance directly. Also, as was mentioned in module section 1, we covered high-speed TCP and MX TCP. Let's get into a little bit more detail here. Regular TCP behaves like this. Time is running along the x-axis while the throughput runs on the y-axis. Regular TCP uses a methodology to avoid collisions called slow start, where it slowly increases the window size until a collision occurs. Once that collision is detected, then the standard TCP stack backs off the window size by 50% and then slowly ramps up again. High-speed TCP helps us to avoid some of the problems with standard TCP By replacing slow start with fast start, meaning we ramp up much more quickly to the bandwidth. Also, if we detect a collision, then we back off only 15%. That's 15%. Notice then that the same amount of data can get transmitted across the network much faster than you would see with standard TCP. Next, we can talk about MXTCP. MXTCP is configured using QoS on the Steelhead appliance. Basically, we specify the amount of bandwidth available to the appliance, and then we utilize all of it. Notice that if there's a collision with any other traffic, we do not back off. Therefore, we need to be very careful when using MXTCP. If there is other traffic on the network that is not being optimized by the Steelhead, that traffic will get clobbered by the MXTCP traffic. So we want to use MXTCP in an environment where we have a dedicated link or in a lab environment where there is no additional traffic to be concerned about. Also, we could use MXTCP in a mixed traffic environment by allocating only a portion of the link to MXTCP. So for example, if we have a link that's 10 megabits per second, we could give 8 megabits to MXTCP and leave the remaining 2 megabits for voice and video traffic, for example. That way, we can utilize all of the 8 meg for the optimized traffic and still leave bandwidth set aside and guaranteed for the jitter-sensitive traffic, voice and video. Configuring high-speed TCP is done in the Configure Optimization Performance section. We check the Enable High-Speed TCP, and then we set the WAN buffers to double the bandwidth delay product. So we multiply the bandwidth times the round-trip delay, and then multiply times 2, and that gives us 2x BDP, and that number is entered in bytes into the form that's located on this page. If you need more information on how to calculate the buffer settings for high-speed TCP, please refer to the manual. And you will be tested extensively on this in the RCSP exam, but not in significant detail on the RCSA exam. Next, let's talk about hierarchical QoS. Hierarchical QoS refers to Riverbed's ability to provide quality of service and guaranteed bandwidth for applications in a hierarchical manner. This means that traffic leaving out of the primary data center in Denver, we can split that up, the 4 T1s, and we can specify that 25% is used for New York, 13% is for India, and 62% is used for the other branches. Furthermore, we can break down the traffic that is going to New York and specify that 66% is for voice and 34% is for other applications. This is what we mean when we say hierarchical QoS. Notice that the type of QoS that we use is hierarchical fair service curve. So that's HFSC. HFSC, and the default mode is not hierarchical, but flat. So if you're asked what the default mode of QoS is, whether it's hierarchical or flat, the correct answer here is flat. We should memorize the 5 different priority classes. The 5 different classes are real-time, interactive, business, normal, and low priority in that order. The default class is normal, and I remember them by writing down at Ribbonal, which was a voice trick to memorize the 5 different classes and their order. Next, let's talk about the encrypted data store. Riverbed provides the ability to encrypt all of the data that's stored in segments and chunks on the hard drives on the Steelhead appliance. That's done using AES 128, 192, or 256-bit encryption. This doesn't have to be done on both sides. In fact, most of our customers, if they're using data store encryption, will turn the encryption on at the less secure branch locations, but when they have a very secure, physically secure data center location, they will not turn on encryption. There is a minor hit. Obviously, when we're doing encryption, the speed when writing to and from disk is slightly slower. That's why we do not want to take the additional hit in the data center when the devices are already physically secure. Let's talk about the proxy file services. Proxy file service is the ability to create a Windows file share on the Steelhead appliance. PFS is rarely used anymore now that we provide the ability to actually run a Windows server on the Steelhead appliance using RSP. However, we will still ask about PFS, as some customers are still interested in providing only a Windows share that can be available. The one thing that's critical to understand is the disk space that is used by PFS is the same as the disk partition that's used by RSP. For this reason, you cannot run PFS and RSP on the same box at the same time. Also note that disk space used by PFS or RSP is not available for the data store. This is not configurable. You cannot take disk space from the data store and assign it to PFS or RSP, and you cannot take space from RSP or PFS and assign it to the data store. This is a non-configurable partition. I've mentioned RSP. Let's talk about what RSP is. RSP is the ability to run VMware Server 2.0 on the Steelhead appliance and therefore run virtual machines in that VMware environment on the Steelhead appliance at the branch. What's very powerful about RSP is the interception technology. The interception technology allows us to insert firewalls into the data path. Remember that the Steelhead is often in a very enviable position sitting between the switch and the router, seeing all of the traffic coming in and out of the network. This allows us to place intrusion detection or intrusion prevention packages as virtual machines on the Steelhead appliance, place them on either side of the Steelhead. Also, we can place a Windows server or some other type of device can hang off of the management interface, which can then be physically cabled to a switch in the branch office. When we think about RSP, PFS, and SDR, as I mentioned, this disk space is referred to as the RSP partition, which is also used for PFS and is specified on the data sheet. Remember that this is not configurable. Listed here are some of the PFS or the RSP packages that are available, and others are coming soon. RSP is priced between $1,600 and $2,600, depending on the hardware, and is available on all XX50 models as well as a subset of the older 20 series models. When we size the RSP, we need to consider the amount of memory that is used by the application that is virtualized and running in VMware. There is a limit of 2 gigabits of RAM on most devices, and the 1050 will allow you to configure up to 4 gigabits of RAM. Next, let's talk about NetFlow. What is NetFlow? NetFlow is the ability to gather data about packets and send that to what's known as a NetFlow collector. We essentially have a NetFlow probe built into the Steelhead appliance. That NetFlow probe can send data to any NetFlow collector, including a Cascade collector. In this version, for this exam, we need to know that we are sending NetFlow version 5 information. Also, statistics for NetFlow are collected in this version as they ingress an interface. And remember that NetFlow runs on UDP. Next, let's talk about IPsec. IPsec allows us to configure encryption between the steelheads. So you can set up an IPsec tunnel between one steelhead and another, and then all of the optimized traffic between those two sites is encrypted. Notice that we're doing DES and null, and that 3DES and AES are supported with the strong encryption license. Remember that we are only encrypting optimized traffic. This means if traffic slips into pass-through mode, it is not going to be encrypted. Please do not consider the Steelhead appliance as a secure channel for unoptimized traffic. Remember that we're supporting IPsec in transport mode and not in tunnel mode. The difference is transport mode encrypts the data of the packets, the payload of the packets, whereas tunnel mode is going to encrypt the entire packet, including the header. Okay, let's look at some sample questions. First question is, if PFS is enabled, what happens to the data store? A, the data store is cleared. B, the data store will be cleared and reduced by 50% to create the PFS partition. Or C, the data store is not affected by PFS in any way. As we just mentioned, PFS is completely separate from the data store, so C is correct. All right, and that's the end of section 4. Thank you.